What if gravity pulled you sideways instead of down? Everything around you, rivers, buildings, even the air, would shift horizontally, changing how you move and live. How would your world look and feel if the force that keeps you grounded pushed you toward the horizon? Let's explore this sideways gravity reality. Chapter 1: How Gravity Works Today. Before we dive into sideways gravity, let's quickly ground ourselves in what gravity is, at least as we understand it in 2025. Gravity is the invisible force pulling everything toward the center of the Earth. It's why when you jump, you come back down, and why the moon orbits our planet. Gravity is the weakest of the four fundamental forces in the universe, but it's the one that shapes the large-scale structure of the cosmos. Scientists like Albert Einstein showed us that gravity isn't just a force pulling objects. It's the warping of space and time around massive objects. A trampoline with a heavy ball in the center curves its surface, causing smaller balls to roll toward the heavy one. That's how gravity works on a cosmic scale. Recently, physicists Mick Parton and Jake Tulkki at Aalto University in Finland have made exciting progress toward understanding gravity within the framework of quantum physics. Their research suggests gravity might be more closely linked to the other fundamental forces than we thought, potentially bringing us closer to a theory of everything that unites all forces of nature. But for now, gravity remains the force pulling you straight down toward Earth's center. Chapter 2: Visualizing Sideways Gravity. Now, let's flip that idea on its head. Gravity pulls not down, but sideways, say, toward the east. You stand on a quiet city street. The sky above is a clear blue, and the sun casts long shadows on the pavement. But instead of feeling your weight press down into the ground beneath your feet, you feel a constant pulling toward the tall glass skyscraper on your right. Your body leans sideways, like a tree growing at an angle. Leaves on the trees flutter not downward but sideways, drifting gently toward the building. Cars parked along the street look slowly sliding sideways, their tires scraping against the asphalt as if invisible hands are dragging them eastward. Buildings themselves would have to be redesigned because the force holding them down would now be pushing them sideways. Walls would be reinforced to resist a sideways pull of 9.8 meters per second squared, or about 32 feet per second, the same strength as Earth's gravity, but acting horizontally. Would rivers flow sideways? Would rain fall sideways? The atmosphere would behave differently, with winds and clouds pushed along by this horizontal tug. This sideways gravity would reshape everything you thought about up and down. Chapter 3: How you would move and stand. So, what happens to you, the person caught in this sideways gravity? First, standing upright as you do now would be impossible. Your feet wouldn't press down on the ground. Instead, they'd slide along the surface like skates on ice, pulled sideways by gravity's relentless tug. To stay still, you'd have to lean into the pull, maybe brace yourself against a wall, or hold on to something solid. Walking would be a whole new challenge. Instead of lifting your feet against downward gravity, you'd be pushing sideways, fighting to keep your balance as your body is constantly pulled toward one side. If you tried to jump, you wouldn't arc up and down but sideways, moving like a diver leaping off a diving board, except the board is vertical. You leap about 50 feet sideways through the air, landing on a wall instead of the ground. Your muscles and bones would adapt over time, but at first, it would feel like you're perpetually falling sideways. Even simple tasks like pouring a glass of water would change. The water would flow sideways, spilling over the rim in a horizontal cascade. Would you feel dizzy? Probably. Your inner ear, which helps with balance, relies on gravity's downward pull. With gravity pulling sideways, your sense of balance would be completely rewired. Chapter 4: What would happen to buildings and things? Buildings and objects would respond differently to this sideways force. Currently, architects design structures to support weight pressing down walls, hold up roofs and foundations push against the ground. But with gravity pulling sideways, buildings would need to be anchored differently. Think of a skyscraper with massive steel cables tethered horizontally into bedrock, preventing it from toppling like a tree in a strong wind. Rivers and lakes would no longer flow downhill. Instead, water would move sideways, carving new channels and reshaping the landscape. Think of a river flowing eastward, parallel to the horizon, instead of downhill through valleys. Roads and sidewalks would have to be designed to prevent vehicles and pedestrians from sliding uncontrollably. Think friction surfaces or barriers on the gravity side of streets to keep cars from drifting. Would trees grow sideways, their roots stretching horizontally to anchor against the pull? Would animals adapt by developing stronger limbs on one side to resist the sideways force? The entire ecosystem would be transformed. Chapter 5. Oceans, Atmosphere and Weather. Now think about how Earth's environment would change if gravity pulled sideways instead of down. Think about the oceans first. Right now, gravity pulls water into basins, creating seas and lakes. But with sideways gravity, water would start flowing horizontally, like a giant river rushing across the planet's surface. Picture the Pacific Ocean slowly shifting eastward, spilling over continents like a waterfall running sideways. Coastlines would disappear or reshape dramatically. Instead of waves crashing vertically onto beaches, you'd see water sloshing sideways, flooding cities and forests in a constant horizontal tide. The atmosphere would also behave in a completely new way. Air, which is currently held close to Earth by downward gravity, would start drifting sideways. Clouds stretched out in long horizontal bands, pushed by gravity toward one side of the planet. Winds would become relentless, blowing in one dominant direction, reshaping weather patterns worldwide. This sideways pull would disrupt the water cycle too. Rain wouldn't fall from the sky but would drift horizontally, creating sideways storms that sweep across landscapes. Rivers would no longer flow downhill but sideways, carving new paths and flooding areas that once were dry. Chapter 6. Planetary and Orbital Effects. But sideways gravity wouldn't just affect life on Earth, it would change how our planet moves through space. Earth's gravity currently pulls everything toward its center, helping keep the atmosphere, oceans, and even satellites in stable orbits. If gravity pulled sideways, Earth's shape might become distorted. Instead of a roughly spherical planet, Earth could elongate in the direction of the sideways pull, like a spinning top leaning over. This would affect the planet's rotation and orbit around the Sun. Satellites orbiting Earth rely on gravity pulling toward the planet's center to stay in stable orbits. With sideways gravity, their orbits would become unpredictable, possibly spiraling out of control or crashing into Earth's surface. Space travel would become far more complicated. Rockets designed to launch vertically would have to be redesigned to launch horizontally or at an angle. Astronauts would experience sideways gravity, making the spacecraft a bizarre experience. Even the Moon's orbit, which depends on Earth's gravitational pull, could be disrupted. The Moon might start drifting sideways, changing tides and causing massive geological upheavals on Earth. Chapter 7. How Bodies and Natural Laws Adapt. Now, let's zoom in on your body and how it would cope with sideways gravity. Our muscles, bones and organs have evolved over millions of years to handle gravity pulling down. But if gravity pulled sideways, everything inside you would shift in that direction. Your internal organs, like your heart and lungs, would be pushed sideways, possibly making breathing and blood circulation more difficult. Your spine would curve sideways, and your muscles would have to work differently to keep you balanced. Scientists studying astronauts in microgravity have learned that the human body adapts surprisingly fast to new gravitational environments. For example, bones lose density in low gravity, and muscles weaken, but the nervous system quickly recalibrates movement and balance. In sideways gravity, your brain would have to relearn how to coordinate movement. Your inner ear, which senses balance, would send confusing signals as it tries to adjust to a horizontal pull. You might feel dizzy or disoriented at first. Chapter 8. Surprising Twist. Here comes the twist. While sideways gravity sounds like a nightmare, it might also open surprising new possibilities. Cities would be designed like giant vertical forests, where people live and work, climbing sideways walls instead of walking on flat streets. Elevators might move horizontally, and transportation could include sideways cable cars or gliders. Sports would be revolutionized. Instead of running races, you might have sideways races, leaping from building to building like parkour artists on a new scale. Think of the thrill of jumping 15 meters sideways through the air. On a larger scale, sideways gravity could inspire new technologies. Engineers might develop friction materials and anchors that work better against horizontal forces. Architects could create buildings that sway and flex with the sideways pull, much like trees in the wind. Chapter 9. What changes and what stays the same? Let's wrap up this journey by comparing the gravity you know with this sideways gravity we've imagined. Vertical gravity pulls you down toward Earth's center, giving you a clear sense of up and down. It shapes everything from how trees grow to how rivers flow. Sideways gravity would flip that on its side, literally pulling everything horizontally. But some things would stay the same. Gravity's strength would still be about 9.8 meters per second squared. Objects would still fall, just sideways. Your weight would feel the same, but in a different direction. Think of it like walking on a steep hill versus walking on flat ground. The force of gravity is the same, but your body and environment adjust to the direction of the pull. Scientists use these kinds of comparisons to understand complex forces. For example, the Sun's gravity is about 28 times stronger than Earth's, pulling planets into elliptical orbits. Sideways gravity on Earth would create a new set of orbits and paths for everything from raindrops to satellites. While the direction changes, the fundamental laws of physics remain constant. Gravity still shapes the universe, but the way it shapes your world would be completely different. So, sideways gravity, cool or crazy? How would you redesign your home and city? Sideways sports, what would they even look like? Let me know what you think in the comments. Thanks for watching. If you enjoy this video, please like the video and don't forget to subscribe for more mind-blowing what-if science videos.